In this video for section 6.1, we're going to talk about how to solve linear systems using matrices. And this process is called Gaussian elimination. So the first step is to write the augmented matrix for the system. Then you're going to use matrix row operations to get the matrix into row echelon form. Now, when we do this, we always start with getting 1 in the upper left-hand corner. Then we use the 1 in the first column to get 0 below it, and then we get 1 in the second row, second column. It's important that you always go in this order when you're doing this, otherwise you could end up undoing steps that you already did. Once you get it into row echelon form, then you put the matrix back into linear equations and use substitution to find the solution. So remember that the first column is going to be coefficients of x, the second column is coefficients of y, the vertical line represents the equal sign, and then the numbers to the right of the vertical line go to the right of the equal sign. So we're going to do an example here of a system with two equations and two variables. We're going to use matrices to solve. So my first step is to write the augmented matrix. So this is going to be 4, -3, and then after the vertical line we're going to have -15, and my second row will be 1, 2, -1. Now, my first step is to change this 4 into a 1. Now, there's a couple of ways that I can do this, but the easiest way, if I have a 1 in a different row, is to just rearrange the order of the rows to move the 1 up to the upper left corner. So in other words, I'm going to switch R1 and R2. So now I have the 1 up there. Now, the next thing that I need to do is get a 0 below the 1. And the way that I do that is I think about what do I need to add to 4 in order to get it to equal 0. Well, that's going to be -4. So what I'm going to do is I'm always going to multiply row 1 by whatever the opposite of this number is and then add it to the second row in order to make a 0 there. So I need to multiply row 1 by -4, because -4 times 1 is -4, and then I'm going to add that to row 2, because -4 plus 4 is 0, and I need to get a 0. So my top row is not changing, only row 2 is changing, and so I'm going to have -4 times 1, which is -4, plus 4 is 0. -4 times 2 is -8. -8 plus -3 is -11. And -1 times -4 is +4. And -15 plus +4 is -11. So this is the resulting matrix. Now the last thing that I need to do is to get this -11 into a 1. At this third step, what I'm always going to be doing is dividing by whatever number is here in order to make it into a 1, because anything divided by itself is equal to +1. So I'm going to divide row 2 by -11. And the way it should work out is it should always divide evenly into the number that comes after the vertical line. So this number divided by this should always be a whole number. If not, that probably means that you made a mistake. In this case, -11 divided by -11 is +1. Now at this point, my matrix is in row echelon form because I have 1s along the diagonal and 0s below. So I'm done with that. Now I can put this back into equations and substitute to find the value of the other variable. Remember, these are coefficients of x, coefficients of y, and we have the equal sign. So one equation is 1x plus 2y equals -1. And my second equation is 0x plus y equals 1. Well, I can just write that as y equals 1. I don't need the 0x. And now I can substitute in order to find the value of x. So I can plug in 1 for y and solve. That's x plus 2 equals negative 1. And I can subtract 2 from both sides and get x equals negative 3. So my answer is the point negative 3, comma 1. So now you should try this checkpoint problem. Do this in your notes, check your answer, and then move on to the homework for this section.